this variable something what you need. So let's look how it looks like. So now I'm reading a audio file, creating its time vector, and now I'm asking user where he wants to make a cut. So here in the command window, you will get these questions. So for example, now I want, and the task is asking you to, like the user, to choose any segment from 50 to 100 milliseconds. So let's try, for example, 100 milliseconds from 700 to 800. Okay, so it's the latest part about the spectrum of the signal. But now let's look what is, we have two new variables, x1 and x2, and it's 700 and 800. And what actually we want to do now, so we have information in milliseconds. User show us that he want to cut that place from 700 milliseconds to 800 milliseconds. But actually now we have our audio signal only here. It is the meanings of audio signal, letter Y. And here we have information only in samples. Here is my Y signal. So I have a lot of values, but it's a samples. It depends on a sampling frequency, which is now 44,100. So I need to somehow convert this information from milliseconds to sample number. I need to know which sample I need to cut. Actually, which sample corresponds with 700 milliseconds and which sample number corresponds to 800 milliseconds. So how you can do that? So actually it's easy, because you need to, that value x1 divided with 1000, because you need to go from milliseconds to seconds. And after that, you just multiply it with sample rate, and the answer is the sample number. And of course, it will be like that, you will get the result, which is not the normal scalar. Yeah, you will get the not scalar value, so you need to round it and get the nearby scalar. So when you round it, you actually get with a little bit of shift, so maybe one sample or other sample which is more closer to your value, but actually it's okay. And after that, when you get these, for example, N1 and N2, you can cut it. So you can create a new variable, Y2, and just show that the value from samples from N1 to N2 from the variable Y will be the new variable Y2. Yeah, and after that, you just need to create also new time vector, which also I will show you a few ways how you can do it. You can create actually like this before. New time vector, for example, T2. So from 0 until length of Y2 minus 1 divided from sample rate. And now we can look actually how it looks like. Now I will show you the plot of original signal and the plot of cutted segment of signal. And I'm multiplying here with the 1000 because I want to see in x-axis, I want to see everything in milliseconds. So now I think we can comment everything what's going on later. because it is the next step. And now let's stick here and let's look what's happening. Okay, so from 700 until 800, and I have a signal. So here is my signal, and I'm cutting somewhere from 700 milliseconds until 800 milliseconds. So yeah, it is, as you see, from 700 until 800, it is here. And I have a signal here. As you see, I cut it. There is nothing after that. But now you see that here we have a time vector. We counting from the beginning, from the 0. So yeah, we just cut it 100 from 700 to 800, and now we see that the new segment now it's 100 milliseconds length. But actually we can do that. We can show that here is the beginning is 700 and the end is 800. We can do it also. So it is the different way how we can create the new time vector. So actually here we just need to create a time vector from n1 until n2. So from sample number n1 to sample number n2 and divide it with the sampling frequency. And in this case, let's try now different place, for example, from 500 to 600. And in result, yeah, now in time vector, you have the values in milliseconds. Actually, it shows the time values the same like in the first graph, in the original graph. Yeah, we can zoom from 500 to 600. Okay, now it's too much. Also a little bit too much. So from 500 until 600, something like that. But actually you see that, yeah, this signal is now, we have the bigger amplitude, just zoomed amplitude. So it's the same signal, but yeah, we can also here correct the amplitude. How we can see now, we see from minus 1.5 to 1, and here only from minus 0.3 to plus 0.3. So the view is different, but the signal is the same. And now we see what we just cut it, a segment of signal. So I think let's stick with this point. If somebody has question about it, and if it's clear for everybody, so we can move on the next. Have you tried